Let's go. So my name is Dalibor. As you can see from my name, I'm from Germany. I'm German. From the lovely city of Hamburg, which I guess used to be part of the Hanseatic League. Riga was part of as well. But that's my only connection to Riga so far yet. This has been my first time here. It's a great pleasure to be here, actually. And I work for Oracle in the Java Platform Group as a product manager, mostly working on OpenJDK and things like that. And today I'll be talking about the things you can work on. Well, you need to work on to prepare your own code for JDK 9, because those jobs are coming. JDK 9 has been in construction for a while, as you can see from this picture. This is a picture of the development team, JDK 9, putting all the modules together. And so we're now at a stage where we can actually play with a lot of this stuff, and I'll tell you what you can play with. But before I do that, last night at a speaker dinner, somebody told me I really need to make sure I engage my audience, because I'm the only thing standing between you guys and lunch. And I think there is nothing better to engage my audience than a well-written legal disclaimer. So I'll let you, take a moment to read and understand it while I take a sip of this wonderful local water. And then what people also say is, okay, but don't people scare people too much, because then they'll be afraid and just go right away. So there is a picture of a guy with a beard. It looks like, like Father Christmas. He's actually Mr. Jean-Baptiste Alphonse Carr, who is lived a long, long time ago and is famous for saying, the more things change, the more they stay the same. And the reason I picked up this quote is that, of course, a lot of things are actually changing in JDK 9. And so there's a few things you have to take into account of these changes that you have to prepare for, but then still a lot of things actually are still remaining the same as you're familiar with them. And to do this, we have a bunch of features listed out in different jobs, and I'll go through each one of them. In some cases, I'll show us a little demo to show you how the things work. And some of the features haven't made it into the JDK 9 early access builds yet. Like I said, this is still in development, so things are changing. This is the status as of about a month ago, and they can still change moving forward. So nothing I say here should be taken as gospel telling you what's going to happen a year from now exactly. But these are the things you can play with today. And with that, I tried to classify some of the changes you should expect in terms of t-shirt sizes, because I noticed in my case, my t-shirt sizes have grown larger and larger over time. So I just started with really large ones. And actually, in my case, it's larger than that, but let's say L is good enough. And the really large change in 9 has to do with modules. So you may have heard about modularity efforts around Java 9. One of the goals behind having modules in the platforms is to provide a means baked into the platform, baked into the language and runtime, that lets you specify exactly all the parts that belong together in a module, in a component, to reuse within applications or even with the JDK itself, allowing you to say which parts of this are types that other users of this module can and should use, and which parts are supposed to be internal, are implementation specific, that others shouldn't really get access to. And so when you apply the module concept to the JDK itself, you end up with the public API that everybody knows, the Java SE APIs, and you end up with a lot of the rest, the stuff that's basically sun, MISC, don't touch this, and so forth, which is part of the internal API. And modules encapsulate internal APIs by default, which means that most of these internal APIs of the JDK, which has so far been rather inaccessible, the compiler would, slap you on your fingers if you try to use it, but you could use reflection tricks to maybe get at it. All these tricks wouldn't work. So most of this stuff would really become inaccessible by default in 9. And that means both at compile time, so the compiler wouldn't let you compile code using such internal APIs to begin with, but also at runtime, the VM would slap you on your fingers and say, no, you cannot access sun, MISC, don't touch this ever, because you're not supposed to touch it, it's internal. And that's new, that's different. So over the past 20 years of Java, even though the compiler has tried to enforce this, the runtime was kind of lenient here and let you actually access things like sunmisk and safe if you really knew how to do it, some special handshake and so forth. And that led to a small number of projects actually relying on APIs like sunmisk unsafe to perform critical tasks that are not supported by the overall Java SE APIs. And whereas in the past couple of years, we've gone through such a code and tried to remove reasons to have such use of internal APIs by replacing internal APIs like Sun, MISC, Base64 with public versions that are supported in Java SE. In some cases, like sunmisk unsafe, that wasn't possible in time for JDK-8. And so a handful of those APIs that are critical and widely used, but still internal, they will remain accessible by default in JDK-9. So sunmisk unsafe, that'll still work if you know the secrets handshake. But they will remain accessible only until there is a supported replacement for such APIs, for most of them at least, in a future JDK release. And then they would also become inaccessible. And so, all right, so you may have heard about the whole sunmisk unsafe being used somewhere, but how do you find out about these things? How do you know? In your code, maybe you can run, grep or something like that to figure it out. Or you can use a tool. And one of the tools we have here is something called JDEPs. Let's see, this works this way. JDEPs, yes. Ha. JDEPs is a static analysis tool that has been shipping as part of JDK-8, so shipping for a while. It can look into your jar files and your class files and figure out what dependencies they have. So what packages, what types the bytecode you're using depends on. And in particular, that means when you use it with specific flags, of which there are many, and you can find them all on the man page. But the one we really care about is the JDK internals one up there. So if you use that flag, it'll tell you if the code you're running or you're analyzing is using any API that's considered to be JDK internal, and that means considered to be inaccessible for JDK-9. So if you run this on, say, on some code, and the question for me here was which code should I run this on, right? I could, of course, take some random project, open source project out there, but that wouldn't be nice. I thought I'd just run this on some of the jar files you'll find in the JDK-9 early access downloads. And in the top level directory of the JDK-9 downloads, you'll find something called jrt-fs.jar. That's new as well. That's the implementation of the file system that you can use to access classes and resources and modules. And this is some new code written in 9. And well, JDEPs does its thing. It analyzes the bytecode, looks at it, and finds nothing. This is great, right? This is as it should be. But the JDK is big, and the JDK is not just big, it's also been around for a while. And so if you look around the JDK installation a bit further, you'll find things like deploy.jar. So that may have been around for a while. That's not something that's been done for 9 specifically. If we run JDEPs on that with the JDK internals switch, it again does its thing, it looks at it, it analyzes, and yeah, all right, there's a few things here. What's going on? So what's going on there is, let's see. No, this is the fun part where I try to bring the mouse over somehow. Okay. So what's going on there is basically JDEPs is telling us which APIs it finds. So it's telling us, for example, that it's found the usage of compsun, deploy, util, yada, 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 within deploy.jar, up to and the top, which uses internally the class Sun Security Util Bit Array, which can be found as a JDK-internal API in the java.base module. And it also tells you helpfully, well, that's not a good thing. You should go and fix this. Well, the JDK team should go and fix this in this case. In particular for APIs where there is, for many APIs where there is a known replacement, there's a known feature you can use instead of the code you have that may have been around since 1.0 or Java 1.2 or whatever. JDAPs will also tell you what types to use instead. So for example, instead of using Sun security provider Sun directly, the proper way to do this since Java 1.3 is to use Java security get provider method and pass it a send selection. And so JDAPs will basically tell you what you need to do, how to do it, and in other cases where it doesn't quite know yet how to do it, in case of, say, Sun Security Util Bit Array, it'll tell you there is a problem here, you have to figure it out. One way to figure it out is to go to this wiki page being displayed in the middle, where information is being collected from JDAPs runs on different open source projects, different Oracle projects, and suggestions like those below are made on how to migrate such code if you have to. And of course, the other way is to look at the Java SE APIs and see what are supported and what you can do to use APIs that actually work with 9. Now, there is one challenge here, though. Not all APIs may have a simple replacement in 9 that may have been encapsulated. So you may end up having to write 2 different paths of code, one for 8 and below, and one for 9. But how do you do that? I mean, the code that uses the methods in 9 that aren't in 8 isn't going to run on 8, so that's not going to work. And the code that uses the stuff in 8 that's not there in 9 isn't going to work in 9, so that's not going to work either. So what do? Do you do reflection? That would be cumbersome. So there is a JAP in 9 that's being backported to 8, which is called multi-release jar files, to enable you to have your jar files carry a version-specific, Java release-specific class file, so that if you have to have, say, a class that has implementation details which are specific for 8 and 9 and which are different and which cannot be built together, then you can separate these out and have a separate version of that class in your jar file by default for 8 and below, and then have a special one for 9, which then the VM will pick up automatically when it knows it's running on 9, using multi-release jar files. This is specified in JEP 238, so if you want to know detail about how that mechanism works, you can look it up in that JEP. All of these things are typically either JEPs, which can be read on the OpenJDK website, or are issues in our Jira web tracker. And of course, there is one last catch. What do you do when none of this works, when there is no help? Well, then you need an escape switch, and there is an escape switch. There is a command line flag described in the JEP above 260, which can help you adjust the encapsulation as a last resort. But because it's a last resort, I'm not going to name it here. You can look it up if you ever need to use it. And this is probably going to be the largest change which has some impact to third-party code using these APIs. It's not just large in terms of impact, also in terms of implementation. For a different scenario in terms of implementation, which is relatively small, but may have larger impact, there is a new feature in JDK 9, which continues on a string of strong innovation in Java in terms of versioning. And Java has always been on the forefront of the industry in terms of finding out new ways to apply versioning. And so after about 20 years of doing things differently, with JDK 9, things are actually moving towards semantic versioning. We'll get a new version string, which uses a more familiar scheme of major dot minor dot security release, which lets us get rid of all these 8U51, 8U75 kind of awkward names for updates. It also gets rid of the rather useless 1 in front of a version number. So your GA version for 9 is then becomes 9 instead of 9.0.0 or 1.9.0. And this can actually trip some code up which tries to check Java version, whether that's the version output of the Java command or the version information containing some system properties like Java spec version, because all these are changing as well to this format. And so if your code is trying to skip over the first digit of a version number, that may be a problem. You need to check that. If your code is trying to assume that versions always have, multiple digits, that may be a problem because GA version string is just 9 and not 9.0.0. So if you have any version checking code, you should test it with JDK9 and look over it to see if it'll still work as it's supposed to work with 9. There are also tools, as far as I know, being written by different third parties, different open source projects to analyze their own code for these kind of issues. You can look for those. And particularly if you're trying to write code that still supports, Java 7, Java 6 users, Java 8 users, and Java 9 users, then that code needs to support both formats for the time you're supporting releases below 9. And the new format looks a bit like this. So we used to have, say for CPU releases, something like 9U5, which in the long form would be 1.9.0_5-B20. That gets translated to 9.0.1, 1 for security, plus 20 for the build number, or 9.0.1 in the short form. For non-security releases, for regular, minor releases, something like 9U20 would then become 9.1. Whatever the security release baseline is. And this is much easier, I think, to parse and much easier to increment, which has been a classic source of confusion around update versions. But it is something to check your code against. Now, with the arrival of modules in 9, given that the JDK itself is modularized, you no longer need to have a monolithic rt.jar file because your class library itself becomes a set of components you can plug together. And so rt.jar makes no sense in that world. And that means rt.jar is gone. Similarly, tools.jar makes no sense in the modular world because all the different tools become their own modules. And so that means the internal structure of what the JDK looks like on disk has changed in JDK9. So there is still a bin directory with the Java and Java C command, but if you look at the lib directory, all these rt.jar files, they're all gone. Instead, there is a new JMod directory with the different modules in there in their own internal format. And if you want to access those, you need to use the new JRT URI scheme to access modules, classes, resources, and so forth from the JDK itself. And so instead of just using Java-lang class directly, you would use the URI JRT, module name, Java base, and then class name to load a class, or also use this to load configuration files and so forth. This unified system works with 9, but also in order to have it work with 8, there is this new jrt-fs.jar file, which implements an NIO file system, implementing this URI scheme, which then works with JDK8 as well. So you can use JDK8 to access resources in a JDK9 modular runtime image. And so the task here is, if you're writing IDEs, if you're writing the kind of tools that need to access or assume a specific JDK layout, because they try to go and dig out different pieces to link to, for example, you need to look at that code and see how it needs to be adapted, or if it needs to be adapted at all in this new world in JDK9 of modular runtime images. So those were the large changes, but I think would affect many developers. Let's go to the slightly smaller ones, medium size. So like I said, the internal APIs get encapsulated. That doesn't necessarily mean they would get removed, but because the ones we we need to keep accessible in 9 are located in sunmisc package, like sunmisc unsafe, because they're critical and have no replacement. And there is a lot of other stuff in packages like sunmisc that isn't critical. That creates a problem. You can't just have one type that the modules can access and not the others. And so that means a lot of the other stuff in sunmisc is actually removed. And the same holds for sun.reflect APIs. The only exceptions are those APIs that are critical in those two packages and don't have a replacement. And there is not a lot of them. There's just a handful. So unsafe, a few APIs around signal handling, and 1 or 2 APIs around reflection. And the reason for that too is that some people implementing, for example, dynamic language in JVM need to have their own mechanism to inspect the stack traces in order to implement proper resolution. And there is a JEP for that in 9, but this hasn't been done in 8, so that means the API stays in 9. All other APIs in those packages like sunmisc base64 will be removed, and in fact have partially already been removed. And that means if you're using sunmisc base64, not even the escape switch would work in this case because the class simply isn't there anymore to link against. You have to fix that code. But then, as everybody knows, since 20 years, you're not supposed to be using internal APIs, right? Another nice thing when you're doing your release is that you can do a bit of house cleaning. And so you can look at the things that have been deprecated in the past and see which one of those can actually be removed from the implementation. And so in JDK-8, there were a few garbage collector combinations that got deprecated. So if you use them in your own code, if you run Java with those flags, you will get a warning in JDK-8 saying, this combination is deprecated. It may be removed in a future release. That future release is JDK-9. So those combinations then will get and have actually been removed already from JDK-9. So if you're using any of those combinations, make sure to check your code, check your scripts, and adjust them accordingly to something that's in JDK-9. Something that may catch a lot of people unaware is that we are really removing deprecated things. We haven't done this a lot in the past, at least not so much in an obvious way. But for example, this happens even in some things that you may not expect. So one of the most common issues I've seen with third-party projects trying to start testing on JDK-9 has been that they're launching the JVM, the JRE, either directly or to JNI, using some VM options that are no longer there in 9, that have been deprecated in 8 already. And so typically that's flags to set the permgen size, which when you're using them with JDK-8, you get a warning message saying, I don't know what to do with this. The VM is basically telling you, this feature is gone. The flag makes no sense. I'll warn you, but this option makes no sense for me because there is no more permgen in 8. In 9, those deprecated options become errors. So you have to go and adjust your scripts and make sure you don't pass such options or the JVM won't even start. It will simply tell you, I don't know what you mean. Please figure it out and then try again. Because again, permgen has been removed for a while. And so the flags to set permgen size just make no sense in 9. And then a release like JDK-9, where you're changing a huge number of things, is also a good opportunity to step a bit back and look at some of the wider features and see if they're actually, still necessary in the modular world. So, for example, there was a feature introduced, I think, in JDK-5 to be able to pick out different versions of a JRE to launch your jar files. By embedding a specific version string or a range of versions even in the manifest entry to ask the JVM to basically delegate the invocation to a different JVM on disk of that specific version. And in JDK-9, that's gone. The specification, if there is one, will be ignored. And so if you do this through command line, the flag isn't there, so you get the same kind of error as before with the permgen. And then the move to the modular world also means that old extension mechanisms, or to extend the JDK installation with new versions of, say, JEXP parsers or JEXWS implementations and so forth, using endorsed standards mechanisms, where you throw a jar file into a JDK installation at a predefined location, and then the JDK installation picks it up automatically and does the right thing, hopefully. They don't really make sense in a world where your JDK comes in as a set of modules, which are encapsulated. And then you try to extend them by replacing some modules with something that's not a module. That just doesn't work. So those old mechanisms are gone in 9. And in fact, if you try to place something in the libx directory or libendorse directory, or even if you use the corresponding system property, you'll get an error when you start a VM. And the VM will tell you this doesn't work, this is not going to happen. In order to prepare for that case, there is a new flag that was introduced in JDK 8 update 40. Check something or other, which will then, when you use it, tell you if you're actually using this system property or if you're using something in those directories, and warn you about it. So you can actually go and figure out if this would affect you. If it does, you should use upgradable modules, which would be a concept I can talk about tomorrow in my presentation here, or simply put the jars you need to put on the class path instead. So aside of the things like that, there are also things that have been part historically of the JDK installation, but haven't really been supported. So if you look at JDK, you'll find a number of tools, for example, like JHAT, that have a very clear statement somewhere in the README file saying this is not supported, this is experimental, or in the man page and so forth. And so again, with JDK 9, this is something one can look at and see, do we still need to carry those things along with JDK 9 if they're experimental and unsupported? If there is value in them, shouldn't we be actually having a supported replacement like we now do with many of the internal features in, say, SunMISC base64, because there was value in having a base64 encoder and decoder built into the platform. And for some of these things, the answer is yes. So for example, when the OS X, OS 10 port was brought into the OpenJDK by Apple and integrated JDK by Oracle and Apple together, we, aside from all the different changes to make the JDK run on OS 10, also received a number of packages implementing platform-specific APIs, desktop-specific extensions that made sense on OS 10, but weren't part of the Java SE specification APIs. And so in JDK 9, there's been some work going on to look at those in a few packages and see what platform-independent alternatives could be provided instead for code using such OS 10-specific APIs to migrate to. And those we provided in the Java AWT package. But it doesn't always work. So for some cases, like Apple's concurrent extensions, those are unsupported and have been removed in 9. Similarly, the Apple scripting engine, if somebody here is using Apple Script. Yeah, that's what I thought. But that's gone as well. So, you know, that's one less thing in the JDK itself. If you need it, though, you can still find the source code in the corresponding OpenJDK source code repositories. Or at least if you find out later you need it, right? You always find out later. And then it also means that a lot of, say, old APIs that have had replacements for a long time, like, for example, the JPEG image I/O APIs that have been with us since, I think, 1.4, something like that, so for a long, long time. And those things, the internal parts of those, that have been there prior to that, they're also gone in 9. And in fact, this is something that's been gone in OpenJDK since forever. So the OpenJDK didn't even ship with those classes. So if your code actually works on OpenJDK VM, this won't affect you. But if you're using, ComSun, image, codec JPEG, this has been deprecated since JDK 7 and it's gone in 9 now. So it's time to step up to Java image IO. Another opportunity you have with a new major release that you can try and look at unifying some things you're doing. And one of the things everybody loves is logging. Not Java util logging, but just logging in general. And so the JVM also has a lot of logging facilities. So you can log the output of the GC, of the JIT, all kinds of things. Except that those logs tend to come in different formats. You have to have different switches to turn them on and off again. And that gets a bit complicated. You can get these wonderful blog posts with 300 hotspot flags everybody should know in user production. So in 9, there is a JAP implementing a new feature which unifies GC logging. There's as part of a more unified logging framework for the VM itself. But it also means that when you re-implement logging with a new framework in unified, some things are going to have to change as they become one rather than many different formats. So the GC logs you get with the JDK9 hotspot VM are in a different format, which means if you have been writing parsers for the output of GC logs, you need to look at the JAP and see if you have to adjust those to be able to still extract information from those log files that you've been extracting before. Most of the common flags people use, like print GC, have been deprecated but haven't been removed. They've been remapped. So the VM will do the right thing in that case. And we may remove them in a later release. But still, if you're writing your own log parsers, this is something to look at because you don't want to discover this in production. And then there is a lot of smaller sized changes. One small, I hope, size change is that there is a new default garbage collector in JDK9 called G1. Small because it just changes the default choice. So typically if you're running something in production, you'll specify your own GC you want to run with, heap sizes, all kinds of optimization flags. So this would only affect people who do not actually care sufficiently about what the default GC is their, say, Java C compiler runs with. So that's why I hope it's a small change, but still it's something that you may need to be aware of if you haven't paid careful attention to what GCs you really want your application to run with, in particular on the server side, because the performance characteristics of G1 and, say, parallel GC, the trade-offs can be a bit different. And parallel GC was the default up to JDK8 on most platforms. There were a few exceptions, mostly to do with 32-bit Windows and stuff like that. It's still there. So of course, if your application requires parallel GC, if that works better for you, you can simply enable it through command line flags by just selecting that GC to run with, if you haven't done so before. But of course, if not, if you're happy with G1, that's great as well. If you find issues with G1 where your workloads regress in some way that you couldn't expect before from documentation and so forth, let us know. The developers are very active on the hotspot usage mailing list and looking for that kind of feedback to be able to make G1 a really great default choice for JDK9, even for the workloads that we haven't been looking at yet. Is there somebody here who actually uses the default GC? Okay, that's one. All right. So you have homework, right? And then other smaller changes and cleanups. So for example, if you look at the JDK downloads, you'll find a bunch of stuff. Besides just the Java runtime, there is also the development tools, and there is some other third-party stuff. And one of those things has been a database implementation called JavaDB, which was introduced a long, long time ago into the JDK. And in JDK 9, it's no longer being planned to be included because it's always been a rebranded distribution of Apache Derby. It has exactly the same binaries as Apache Derby, which means people who really need to have Apache Derby can simply get Apache Derby from Apache. There is no pressing need for the JDK to actually also deliver this as well. This was, as you can see, announced actually quite a while ago, back in June on the Java Platform Group Product Management blog. This is over on blogsoracle.com, a place where my colleagues, Donald Smith and Eric Koslow and so on, regularly blog about things that may affect our users on JDK 8, on JDK 9, upcoming features and so forth. So if you haven't been, having this in your RSS feed, I'd suggest doing so because a lot of the information coming there can be quite useful, in particular as JDK evolves. And every now and then I also get to have a little post in there. So one of the changes in JDK 9 is that the plugin implementation is deprecated. Is there somebody here still writing plugins? Still writing applets? I'm sorry. I mean, I guess the reasoning is clear. If you look at the web, the browser vendors have really been trying hard to move past plugin implementations, and so they've been limiting those APIs. They've been removing those APIs and providing very strict timelines on how they want to stop providing at least standard-based plugin support. And that means if you're still working on applets, the plugin is not removed in 9, but it may be removed in a future release. And that means you need to look at plugin-free alternatives. For example, Java Web Start or desktop applications or what have you, whatever suits your requirements. So to sum up, what can you do to prepare for this? Well, actually, in the keynote, Simon mentioned the Adopt OpenJDK efforts, and as part of the adoption group in OpenJDK, we have our own wiki space where we are collecting information on all these kind of changes which may affect your code at runtime, at build time, and so forth. So you can go there to get the latest sort of overview about what gaps are being targeted that may affect your applications. In particular, what you can do today is to check your own code for any usage of JDK-internal APIs using the JDEPs tool. Preferably using the one from JDK 9 or the one from the Jigsaw EA builds, because those are effectively always more up to date with whatever the latest replacements are. So they'll give you better suggestions. But just checking your own code and finding out that you may have some technical debt to address in the coming months until JDK 9 is there is, I think, very useful because it lets you plan ahead for when 9 ships. If you have to adjust anything, knowing things well ahead of time is quite useful. And of course, if you find that your own dependencies have issues where they use JDK-internal APIs, well, talk to those developers of those dependencies and see if they're, already have plans to address those issues, maybe file bug reports and so forth. Because of course, if your dependencies use internal APIs and don't work on 9, you still have a problem. And if you don't know what your dependencies are, now is a good time to find out, right? If you're developing tools that work on the bytecode, like IDEs or language implementations or whatever you have, now is a good time to check if your tool really depends on a specific layout of the JDK installation or the JRE installation. So if it requires rt.jar, tools.jar, those things. And if it does, now is a good time to start playing with the JRT file system and using those URIs to access those JDK-specific resources in a way that's JDK release independent, so that your code doesn't get stuck, not working on 9. Also, if your code is doing any versioning checks, look at the version specification updates in 9 see if there's anything you need to do. In most cases, you probably won't have to do anything because your code is going to be, well behaved. But in some cases, you might, and it's always better to find these things out before users find them out. There is also something I didn't mention. There is actually a small language change in 9, really tiny one. So underscore, for those of you who love underscore as an identifier, you've been getting a compiler warning with 8 that underscore as an identifier may be gone in a future release. And again, the future is now, right? The future is JDK9. So the underscore is no longer a valid identifier. And that means you have to find some other single character thing to abuse if you have to. So we're taking it back. And then, of course, in particular for your scripts, firing up VMs, make sure that they don't use any VM flags that have been deprecated, where you get warnings already on 8. But you can find this out really easily by looking at your logs on 8 and seeing, if you get any warnings from the VM already. And most importantly, make sure to test your code with early access builds. So JDK9 early access builds are provided regularly on the, let's see if this works. Okay, mouse over here on jdk9.java.net, and you can get them for your family favorite platforms, whether that's Oracle Solaris or Windows or Linux or what have you, OS 10. You can also get early access builds with Project Jigsaw with the modularity features if you want to play with those already, test and let us know if things break, because we want to know this well ahead of time, so that we have time to address it. As part of this, I mentioned the adoption group's quality outreach efforts. So that's on the OpenJDK wiki. And there you'll find regularly updated list of changes that may affect your code, depending what your code does, things that have been added, changed, removed, things that may affect your build even. And one fun thing I didn't mention also here is this bit. So support for compiling down to 1.5 has been removed in JDK9 as per the JDK policies. So if you're cross-compiling with JDK9 for really old releases of Java, you have to look in different ways of doing this. On the other hand, there is a new good thing in 9 about this, is that it actually provides support for defining platforms to cross-compile to, which eliminates a whole class of errors a lot of people do when they cross-compile to older releases of the JVM by forgetting to use the proper RTJR file in that case. And if you're involved in an open source project, I recommend getting involved in the OpenJDK quality outreach efforts, where we have by now around 50 projects regularly participating in testing early access builds. A lot of Apache projects, a lot of others who've been providing great feedback over the past 2 years. More than 100 bugs logged, 100 issues that they found, and let us know about in the EA builds that have been able to look at and see which ones we could fix, and typically high priority issues. And the reason behind this is very simple. There are a lot of projects out there in the open source space that use Java, that work on the JVM, that have a much easier time to upgrade to new versions if they're actually able to test ahead of time and have their issues resolved as they find them. So we try to reach out to them, the ones we know at least, and make sure that they are aware of the changes that are upcoming in future releases. They're aware of bug fixes that would affect them. And so if this is something you're interested in, come to me after the session, talk to me, and I'll be happy to help you get signed up for this. And of course, this is something we love to do with the community. All that being said, I think my time is almost up. So that means now it's probably time for questions or for answers. I can ask questions, you can give answers, right? No. Do we have any questions? Are you really afraid now of 9? Yes, a little, right? Okay.
I got a question regarding the disallow of uses of underscore. Is that a restriction at the language level or at the JVM level?
Language level. further questions? Or does anybody have a better answer? That works too, right? I mean, I don't want to keep you guys too long away from lunch. So, I mean, if there are no questions, feel free to come to me afterwards and grab me during lunch, and we'll chat. Thank you so much for your attention, and enjoy the conference. See you tomorrow.